Well, good evening, students. So today we are discussing yet an harder topic. So this topic for most of the students is considered to be headache problems. Okay, projectile motion. Projectile motion, there are several equations. In spite of studying so many equations, practicing so many times, still in an MCQ, a student will make a failure, will not be attempting properly. Now let us look at this problem. The problem appears to be very simple. Okay, again, blind intuition or guesswork, okay, is the reason for making this or getting an error here. So you have a marble here and you are throwing this with a velocity. The height of this is given to you. Okay, let us say its velocity is v. Now if I double the velocity, now when I throw it to the velocity v horizontally, what will happen? The marble will come and fall here. The marble will fall here. That's what will happen. Now, if I double the velocity, that means I'm throwing it faster. Then what happens? The marble will now take a path like this and will fall here. It will fall here. It will fall farther from the wall. Okay. Now, what will be the difference in the time for the marble to reach the floor? Usually, what students do is they consider marble thrown with the larger speed will reach the floor sooner. There's one answer I expect. Okay, I do get it in the answer papers. The second answer they do is that marble thrown with a larger speed travels a larger distance, and as a result of it, will reach the floor later. Okay, so this is what we have. Usually, what the MCQ will have is that if T1 is the time taken by the marble to reach during this fall, and T2 is the time taken by the marble to reach this fall, then the options in the MCQ would be T1 greater than T2, T1 greater than T2, T1 less than T2, T1 is equal to T2. Three options. The fourth one could be none of the above. Okay. Now, what do you think would be the right answer? So, most of the time I get this answer, that is T1 less than T2, something like 70% of the time I get this value, which means that it takes lesser time because you're throwing it with a larger speed. 30% of the time I get this one. I never get this information at all. This answer, I never get this. But fortunately, this is the right answer. Let us see, why do we get this? Where is the mistake in the understanding? The mistake in the understanding is that when somebody says T1 less than T2, that means, let us say here, it takes something like 5 seconds. And here, let us say it is 7 seconds. We say 5 seconds is less than 7 seconds. Okay, so what happens is they think that since it is not going farther away, it reaches a shorter distance. So time taken should be lesser. So they get confused this projectile motion with that of a linear motion. Okay, it is something like you have a block of mass m and you give some push. Okay, it travels a lesser distance. And if you given a larger push, okay, then maybe velocity is larger. It would have traveled a larger distance. Okay, so the time taken to reach this OA is smaller. Time taken to reach OB is larger. So as a result of it, they get this answer. Okay, do not get confused with a linear motion with a projectile motion. These two are two different motions. Okay, so guesswork is a major culprit, okay, to get an incorrect answer. So you do a guesswork here. So that's where you make a mistake. Now, if that is the case, let us try to solve this. Now, towards it, the first thing is in a projectile motion, always students make one big mistake. Okay, until unless I don't give it as a projectile motion, they don't realize it. And if it is said to somebody that it's a projectile motion, the first thing they do is that they start using T is equal to 2uy by g. You know, when can you use this? You can use this only when the projectile's x coordinate, that is a starting coordinate, x coordinate, and the ending x coordinate are on the same line. Okay, or its net displacement along the y-axis is 0. Remember this. Okay, so whenever you throw a projectile, you can use your standard equations like 2 equal to t equal to 2uy by j, range is equal to 2 ux uy by g, and you have h equal to ui square by 2g. So these three equations can be used only when the net y displacement is equal to 0. Now here you see, is the y displacement 0? Y displacement is not 0. See, this is my y displacement. This is my x displacement. So what usually students do is they consider that if at all, if I had thrown a particle from here and it had gone all the way along and gone all the way along like this, okay, it will consider time t. Now, since it is describing only half a circle or half a curve, so therefore it should be t by 2. That's what they consider, which is completely wrong. Okay, we should not do that mistake. Now, how do we solve this? So, which means that whenever you have a horizontal projectile motion, see, this is a horizontal projectile. Why horizontal? Because you're throwing it horizontally. Horizontal projectile motion. You are not going to use these equations. You are going to use another set of equations. What are they? That's what we are going to look into. Now, towards it, now we are going to divide this motion into two parts. What are they? First is along the x-axis. The second one is along the y-axis. Now, first let us understand the y-axis motion. Let me consider anything along this direction is positive. Anything along this direction is positive, plus y. So if I measure something downwards, it is negative. Okay. So let us use the equations of motion. So why should I use equations of motion? The reason is because now we are discussing the motion of the particle in gravitational field. So it will experience a value equal to g. Acceleration due to gravity is g always, right? So let us use the equations of motion. So minus 1.8, the displacement from here to here, minus 1.8. Why minus 1.8? Because I'm measuring it downwards. Should now be equal to ut. What is u here? This is uy into t. I first let me write down the equation, then I'll substitute. Uy into t plus half ay into t square. This is what I will get. Now towards it, what is uy? Uy is nothing but the y component of the velocity. When you are throwing it horizontally, do you have the velocity vector directed downwards? Do you have any speed downwards? There is no velocity vector. You are not throwing it downwards like this. You are only throwing it horizontally. So therefore, your y component of the initial velocity is 0. Okay, plus half into ay. What is ay? Ay is nothing but g, right? You threw it horizontally. You did not throw it down. So therefore, the only force that is acting here is the gravity force. Now, its direction is downwards. So should this be plus g or minus g? This should be minus g. So this is minus g into t square. Okay. So therefore, now what I will do is I'll write minus 1.8 is equal to minus. Now this is, let me take g equal to 10. When you take g equal to 10, what will happen? This will become minus 5 into t square. This minus and minus get cancelled. So you get t square is equal to 1.8 divided by 5, which should now be equal to, so somewhere around 3.6 divided by 10 or 0.36. This is what I get. So if you ask me what's the value of t, I'll get this as square root of 0.36, which should be, how much will this be? I don't use a calculator. Okay, I directly do it, which I do write it as 36 into 10 power minus 2, which I can write this as 6 into 10 power minus 1, which is 0.6. What is the unit? Second. Now, while doing all these calculations, did I ever use the value of v? See, this v is in this direction. See, I had used uy, but uy is 0. Whether you threw this with a velocity of v, or 2v, or 3v, or 10v, whatever it is, see, there is no dependence on this v here. As a result of this, the time taken here to fall down, okay, is independent of the velocity, which means that whether you threw it with a velocity v or 2v, 3v, every time it reaches the ground only in 0.6 seconds only, right? Logically, when we thought of, okay, we thought, okay, either this or this is correct, but both of them are incorrect. So what is correct here? T1 is equal to T2 is the correct answer. Okay. So therefore, so if this takes 5 seconds, this should also take 5 seconds. Okay. So, but what differs? If I change the velocity, if I double the velocity, triple the velocity, what can happen? The particle can either fall nearby. If I increase the velocity, it will fall farther away. The distance moved by the particle along the x-axis will increase. Okay. While the time taken to fall will always remain a constant. It does not change. Okay. So with this, let me stop here for today. So next class we will see tomorrow. I hope you would have understood this clearly. Okay. Thank you, friends, for watching the video. Like, share, comment, and subscribe on the channel to get further updates. Thank you.